So covering the distance time graph, after that we are having velocity time graph. Okay, distance time graph was giving you the idea of speed. So here velocity time graph will gives you an idea of acceleration. Yeah, definitely acceleration is equals to change in velocity divided by time, or velocity divided by time will also gives you the idea of acceleration. So here also we are having some graphical representations that are like this. So here you can consider that this part would be, earlier this thing was at rest motion. Yes, that is rest position in distance time graph. Remember? But here this is another thing. Here in this case you are having no acceleration. Body is at motion. You do not consider it like the body is at rest right now. No, it is in motion, but no acceleration is here. Why? Because velocity is not changing. Velocity is constant. Velocity is constant. It is not changing with respect to time. So we can say that acceleration is not going to be performed here, but velocity is there. Velocity definitely will be the part of here, that the body is in motion, but the speed, the magnitude, the velocity is not going to be changed. So we can say, we can predict with this graph that there is no acceleration. Okay, now there is a second example. So what do you consider with this? That here is acceleration or not? Yes, definitely here is acceleration, and that is uniform acceleration. So why we are calling it as uniform acceleration? Because definite proportion of velocity is changing with the definite time. In a particular interval of time, definite quantity of velocity is changing again and again, that like in the similar way that we have considered in earlier distance time graph also, that like this is a graph of velocity and time. So definite proportion, let's suppose this particular part is 5 meter per second velocity and the time considered here is 5 seconds. If we take another proportion of it, 5 meter per second velocity again, and again it has been changing in the time 5 seconds. So 5 second time is required in changing the 5 meter per second of speed. And why? How we get this 5 meter per second part? By difference between the initial and the final velocity. Yeah, you remember, very good everybody. So here is the uniform acceleration part. So whenever you see such kind of graph in which velocity and time is mentioned and the slope is straight, so like this, okay, with at particular angle also, so you can consider this as a uniform acceleration. Okay, so then what is the graph for non-uniform acceleration? Here we are having a non-uniform acceleration graph, that is a curved graph. Earlier in the part of distance time graph, we are having that as a non-uniform speed, right? Remember? Okay, so here also it is considered as a non-uniform acceleration because the velocity part is changing again and again, but not changing in a fixed manner. Yes, time is fixed, that you cannot control, but the velocity part is changing, but changing with sometimes it is low and sometimes it is high and more high and more high. You can change it in any manner, okay, but it is changing with different values. So we can say that this graph is non-uniform acceleration. So yes, graph part has been done from here, and now moving forward we are having the most important part, that is the equation of motions and their graphical method. Yes, we are having the three most important equation of motion that has been delivered by Newton sir. Yes, and you have to remember those equations throughout of your life, dear all, if you are going to be a science student in future. Okay, so here are having some graphical method to represent the equations of motion. motions. Okay, earlier you have seen two kinds of graphical modes, that is distance time graph and velocity time graph. Okay, so here we are having distance time velocity time relation with the help of the graphical method. Okay, so here is the basic mode of graph we are having. You can see here there is a velocity time graph and the slope is starting from some point, some initial point is here from where the slope has been starting. It is not going to starting from zero, and we are considering it deliberately. Why? Because keeping it from zero will be easy task for calculation also. But if something is not going to be start at the zero mode, it is going to be start at some particular, or we are considering it from some particular value, so that in that case what you are going to choose. So here is the first equation, that is v is equals to u plus at. Here v again is the final velocity, u is the initial velocity, a is the acceleration and t is time. Okay, now see, this is velocity time graph and the slope is like this. So by chance we can put like this, we can combine the end point of the slope to the y-axis, and we can combine the end point of the slope to x-axis also. Okay, and the starting point also, the starting point is already connected to the first that is y-axis, but if we want to check whether it is connected to this point, so we can draft it like this. Okay, we can draw it like this also. Okay, so what is the use of this thing you are going to see in later on. So but firstly consider this velocity time graph, and you know that velocity time graph gives you acceleration. Yes, that is why in this equation you are having acceleration part also. And remember that velocity divided by time gives you acceleration, change in velocity gives you acceleration. Okay, so here we are having a relation that in this diagram you are having that OA part is equals to the CD part. Okay, so CD is parallel to OA. So we can say that OA is initial velocity, because at this particular point, at this initial point, you are having U. It is starting from this position A. So you can say that A is initial velocity, and B wherever the B is ending and it is combining at E part. So you can tell us that E is the final velocity. So here we are having OE, you can see here also OE is equals to CB, and it is again equals to V, that is final velocity. Okay, now see OC and AD both are parallel and will give you the idea of time, because x-axis always gives you time. Now BD and BC minus DC. BD is this part, okay, and BD, that is C is here, students. Okay, so BC minus DC part, that much part, if we cancel that much part from this part, so you will get this part only. Okay, that is the change in velocity. What was the change? What was the initial? That is the initial position and that is the final position. So here is the change part also. Okay, now therefore we can say that BC is equals to BD plus DC is equals to BD plus OA. In place of DC we are putting OA because both these lines are parallel. Okay, now moving forward you can see BC is equals to V because BC is the final velocity right now and OA is the initial velocity. So we get, putting it in the first one, V is equals to BD plus U. Now there is no chance that BD is going to be changed. Okay, so what is BD here? So for BD we are going to be get the value, particular value. That is BD is equals to V minus U. Okay, that is our first equation. So yes, for the value of BD we must have particular value and we are going to find it by ourselves. According to our graph, BD is BC minus DC, and we have already discussed that DC is equivalent to AO part and AD is parallel to OC part, and with that value we have find that BD is equals to V minus U. So here in velocity time graph, that slope gives you acceleration, so we can say that A is equals to BD upon AD is equals to BD upon OC. Okay. So AD part can be covered as OC. We can replace it because these two lines AD and OC are parallel to each other. Fine, no problem in that. Okay, so moving forward, again we are having OC. OC gives you time, and any kind of time is it having, so we are letting it as T. Okay, कोई भी time हो सकता है, वो 5 seconds, 10 seconds, anything. So here you have to write it as T. So here we are getting A is equals to BD upon T because AD is parallel to OC. Okay, no problem in that. Okay, now moving forward, so we get to know that BD, that is BD is equals to A multiplied by T. Cross multiplication part is there now, like A is equals to BD upon T is written. So if we are cross multiplying it, so we are getting BD. So here we are get the value of BD. By this we are getting the value of BD, that is A multiplied by T. Okay, so that is the second part. So earlier first part, and if we substitute the value of BD in that part, what you will get? We get BD is equals to V minus U. That was the first equation, and putting here AT, acceleration multiplied by time, you will get V minus U. So here you are having the equation like V minus U is equals to AT.